Presentation on LED TV presented by Azimuddin and Nawaz Muhammad Raihan, submitted to Rahul Choudhury, lecturer, Department of Tripoli, Premier University, Chittagong. These are the contents: introduction, history, working principle, types of LED TV, uses of LED TV, conclusion. Introduction. A flat panel LCD TV set that uses LEDs for its backlight source rather than the earlier cold cathode fluorescent lamps. Smaller, more power efficient, and having a greater optical range than the fluorescents. LED TVs produce deeper blacks and more saturated color. Although an LED TV is really an LCD TV with LED backlighting. The industry branded them as LED TVs to avoid monikers such as LED backlit TV or LED based LCD TV. Today, most TV sets are LED TVs.
Now, we will be talking about history. Light-emitting diodes came into existence in 1962 and were primarily red in color for the first decade. The first practical LED was invented by Nick Holoniak in 1962 while he was at General Electric. The first practical LED display was developed at Hewlett-Packard and introduced in 1968. Its development was led by Howard C. Burton and Gerald P. Figini at HP Associates and HP Labs, who had engaged in research and development on practical LEDs between 1962 and 1968. In February 1969, they introduced the HP model 5082-7000 numeric indicator. It was the first LED device to integrated circuit technology and the first intelligent LED display, making it a revolution in digital display technology, replacing the Nexi tube and becoming the basis for later LED displays.
Early models were monochromatic by design. The efficient blue light completing the color triad did not commercially arrive until the late 1980s. In the late 1980s, aluminum, indium, gallium phosphide LEDs arrived. They provided an efficient source of light, red and amber, and were used in information displays. However, it was still impossible to achieve full color. The available green was hardly green at all, mostly yellow, and early blue had excessively high power consumption. It was only when Suji Nakamura, then at Nichia Chemical, announced the development of the blue and later green LED based on indium gallium nitride that possibilities opened for big LED video displays. Working principle. A TV monitor has many LEDs. These components replace the cold cathode fluorescent lamp, which are part of LCD TVs. This is the difference between LCD TV and LED TV. The great advantage of LEDs is the energy saving. The TV LEDs stay in a matrix and are controlled by an electronic circuit called driver. Polarizing light. The LED TV polarizes light the same way as the LCD TV. Has glass filters, polarizers films, and a LCD layer with thin film transistors, which are electrically controlled by the subpixel electrodes. This figure shows the screen structure of a LCD TV, which is the same from a LED TV, except the LED matrix instead of fluorescent lamps. The light is an electromagnetic wave, therefore has electric and magnetic fields perpendicular to the propagation direction. The non-polarized light has electrical field scattered in random planes. Exist polarizing filter which allow only one of the light's electric fields pass through. Vertical polarizing filter allow only electric fields and horizontal polarizing filter only let pass horizontal field.
Liquid crystal. The liquid crystal is a substance in a physical state between the solid and the liquid, and the air molecules are positioned almost in the same direction. The liquid crystal can be divided in other physical states. Nematic phase is a state similar to liquid, but the molecules point to the same direction. In the schematic phase, the molecules get arranged in layers one above another. In the cholesteric phase or twisted nematic, the molecules oriented in each other remain a spiral. The display. A crystal in cholesteric phase submitted to an electrical current change to a nematic phase in many degree dependent on the applied tension. When an electrical field is not applied, there is a light passage. With electrical field, there is not light passage. In a LCD, each pixel is controlled separately electronically, reproducing the colors. The blacklight LEDs emit white color, which is the sum of all other colors. Each pixel has filters of three primary colors: blue, green, and red. The pixel color depends on the polarization of liquid crystals, which are controlled by thin film transistors. The combination and intensity of three primary colors can produce all other colors.
Now types of LED TV. Edge-lit LED. An edge-lit LED screen does exactly what it says on the tin. Two rows of LEDs will light the screen pixels from each side. This screen lighting method is more prone to suffer from light bleed between different areas of the screen, as the contrast between light and dark cannot be well replicated when the light source for both is being emitted from the same part of the screen. Full array LED. A step up from edge-lit models, a full array LED screen is fully backlit, meaning the LEDs are evenly distributed behind the entirety of the screen. This results in a better contrast as light is focused on the area of the screen that needs it and dimmed in darker areas of the screen. This is an effect known as local dimming, by which the luminosity of the particular area of the screen is boosted or dimmed depending on what the picture requires.
QLED, quantum dot light emitting diodes. This is a form of LED developed by Samsung, which uses quantum dot technology to achieve better brightness and color. QLED provides a step up from both edge-lit LED and full array LED, but isn't quite as good as OLED because each LED and pixel are not combined. OLED, organic light emitting diodes. OLED screens combine the LED with the pixel, meaning each pixel is able to create its own light source. This makes OLED the best choice for contrast between light and dark, as each pixel is able to turn off its own light source completely in areas of the screen that should be dark. This allows for each object to be individually rendered. and color bleed, which might affect some lower quality screens, is non-existent.
Uses of LED TV provide information to the public, offices, government institutions, transportations, shops, rooftops, and streets. Broadcast live events, home entertainment, news, sports stadiums, concerts, talks presentation, and other events. Advertise brands and products, digital LED billboards, LED TV on shop window, conference rooms, and corporate receptions.
Finally, the conclusion. LED TV is actually LCD TV, but instead of CCFL as light source, we use LED as blacklight in LED TV. LED is more energy efficient than CCFL. That will make LED TV screen more slim and lightweight. Technically, we can say LED as blacklight LCD TV. The future will see new types of screen technology such as micro LED and mini LED. These are meant to rival OLED, but with the typical efficiency and cost benefits of LED based technologies. That's for all. Thank you.